Hi guys, we are going to continue on working on chapter 19, and of course now it's the turn for lesson 19.4. Okay, we are going to talk about compound events. Now compound events, it's pretty simple. We only need to think about how do we get together two or more events. So instead of just asking when rolling a die, what is the probability of getting a prime number, we're now going to get two or more events. So probably getting a prime number and odd and greater than 3, right? And so we would be working on a compound event. Now here, think about that compound events are always going to be calculated. Their probability is going to be calculated in terms of how two events are multiplied. So I need to get the probability of the first event, and then I need to multiply it with the probability of the second event. All right? And we're always going to write it down as the probability of the first event and the second event. Now, in terms of compound events, since we are getting together events again, we need to be able to determine whether we're dealing with independent events or we're dealing with dependent events. Think about independent events as events that are not going to be influenced by the occurrence of another event. So maybe getting marbles out of a bag and then getting that experiment along with another experiment that can be rolling a die or rolling a spin, right? A spinner. So then I can get the probability of drawing a blue marble and the probability of spinning the spinner and getting the arrow to fall on the A section. So that would be independent events. Why? Because I'm asking for two very different events where the occurrence of one is never going to influence the occurrence of the other. All right? This is what we need to keep in mind here. Now, dependent events, though, it's very different in terms of how careful you need to be when you find out two events are dependent. Dependent means that I probably want to get a card from a deck of cards, right? The poker cards. So think about I want to get 5 of hearts. If I want to get a 5 of hearts, then that's going to be an event in the experiment of getting a card from the deck of cards, right? But then how about I want to think about getting another card, say 10 of diamonds. So that would be another card from the very same deck. Those two events are actually dependent. Why are they dependent? Because they belong to the same experiment. Since they belong to the same experiment, then something is going to happen there that is not going to make everything work as if we would be working with the independent events. But I will let you know that once we start working with exercises, okay? Just think about this. Independent events usually belong to different experiments. That's why the occurrence of one event doesn't affect the occurrence of the other. But dependent events a lot of times actually belong to the same experiment. That means the sample space is the same for both. And when I'm taking something or I'm using one of the pieces in the sample space, then the sample space is going to change if I want to do it a second time or a third time, right? Think about a bag of marbles. I can have compound events working just with a bag of marbles. So I can have the bag of marbles we had on last week, right? And I can draw a marble, take it out and leave it out, and then draw another marble. That's going to make everything change. Why? Because the total of marbles that are inside the bag are not. It's not the same the second time. I'm having -1 marble in the bag. And so that's going to change everything. I'll show you, okay? I'm going to work with you on the first 6 exercises of the lesson, so that is going to allow you to actually work with everything else and to understand what I'm trying to tell you in terms of how to determine that, what is an independent or what is a dependent event, and also how to find the probability of compound events, whether it's one of the two, okay? Let's begin with problem number 1. Problem number 1 tells us about having a spinner and having a die. And we're rolling both. So we are spinning the spinner and we are rolling the die. And we want to find the probability of getting 1 in the die and getting blue in the spinner. That is a compound event. Why? Because I know I have 2 events here. First, to get 1 in the die. Second, to get blue in the spinner. It is a compound event. And I need to get the probability of that event to happen. How is that going to happen? Well, first thing I need to figure out is whether they are independent or dependent events. Now, if you think about it, getting 1 goes with the die and getting blue goes with the spinner. So they belong to different experiments. And getting 1 in the die is never affected by getting any color in the spinner. So I'm fine. I know here we're working with independent events. Okay? Now, if we know that, this is how we are going to work. What I need to find first is what is the probability of 1 to happen. Well, I know the sample space in the die is 6, and I only have 1 option here, so it's 1/6, right? Now, the probability of getting blue is actually 1 as well, but this time the sample space is 4. So I know it's 1/4. Now, please remember, when I want to find the probability of a compound event, I need to get the multiplication of the probabilities of each event. So I know here the probability of 1 and blue, it's going to be equal to the probability of 1 times the probability of blue. And this is, of course, 1/6 and 1/4, and that is 1/24. Now, as you know, we're going to always give the probability in fractions, decimals, and percents. So here my math told me this is the decimal. And of course, I need to multiply by 100, right? Moving the point twice to the left, to the right. And so that's going to be 4.17%. That's the probability for those 2 things happening at the same time when I'm rolling each, the die and the spinner. Let's go with problem number 2. Now we need to figure out what is the probability of getting a 4 in the die and not blue in the spinner. Now we need to remember about complementary events. Remember, everything that is not blue is what I need to take into account here. So first, I'm going to get the probability of 4, which again, gotta be 1/6. Same thing, right? Only 1 option out of 6 options I have in the die. And then probability of not blue. Probability of not blue. Well, think about the spinner. What is not blue in the spinner? Red, green, and yellow. So I have 3 options, right, that are not blue out of 4 possible options, which is the sample space. Then, of course, we know we're going to get the probability of 4 and not blue. So we need to multiply the experiments. So that is probability of 4 times the probability of not getting blue. And that is going to be 1/6 times 3/4. Now, you know, we can simplify that multiplication of fractions. So here I get 1 and here I get 2 times 3. So that's why the 3 gets canceled. And so I know this is actually going to be 1/2 times 1/4, right? And this gets us into 1/8. 1/8, the decimal number here is going to be 0.125, and I know the percent is going to be 12.5%. Okay? All right. Now let's do number 3. Number 3 is nothing but actually keeping the same analysis skills here. Because if you think about number 3, which tells us that we need to get the probability of yellow and an odd number, right? Then again, we're gonna find the probability of yellow, which is the spinner, of course, because it's the one that is working with colors. So I know it's gonna be 1/4, right? 1 out of 4. And then I'm gonna get the probability of getting an odd number in the die, when I'm rolling the die. That, of course, is gonna be half, right? So 3 options out of 6. And you know what? I'm going to simplify it right away. That way, it's gonna be easier for me. So I know the probability of yellow and an odd number. It's gonna be multiplying those 2 probabilities that I got separately, right? And then we're gonna get the probability of yellow. There we go. It's gonna be, 1/4. I was looking for the decimal, but we're not gonna get it yet. And the probability of odd is 1/2, right? So again, we're actually getting the same 1/2, and we already have those numbers here. So we know this is going to be the same 0.125 and the same 12.5%, okay? That easy. That's the way it works. Let's go ahead and work with a different type of exercise. In this section, you can see how everything is changing. First thing they tell you is, yes, we're gonna find the probability of a compound event. Here, we're not using the word and, right? Specifically, the comma also says and. That is a little change. But also, here in the enunciate, they say the first card, we're taking cards. We have 2 blue, 3 red, and 1 yellow card. And they tell you, get 1 card, then get another. So we're talking about the same experiment. But they also tell you, you know what, the first card is not returned. So you're taking the card, but you're not returning it. If you're not returning it, then how is everything gonna work, right? But this is very important. First, both events belong to the same experiment. But second, and more importantly, the first card is not returned. So that tells me that whatever is happening with the second card is actually affected by what happened with the first card. So, if the first card gotta be blue, I need to find the probability of getting blue first. You can tell us 2 cards, 2 outcomes out of 1, 2, 3, 4, 5, and 6, right? So we can tell that is 1/3. We wanna simplify it right away. Now, the second probability, again, is being influenced by what happened in the first. And so, yes, I need to get yellow, which is, of course, only one option. But since I didn't return the first card, then I need to think about that I'm not having 6 cards anymore. Now what I'm having is 5 cards, because I don't have a blue card anymore. I took it and I put it out. So I'm only having 5 cards, okay? Here, we can actually say then that we are working with dependent events. And that's what happens when we have dependent events. When we have dependent. When we have dependent events, well, the total is going to change. Because if I'm not returning the first card, I'm always going to have a different total in the second card, right? You got to keep that in mind. And that's what dependent events do. They always change what happens after the first event. Or even if I have 3 events here, then the third event will also be affected, and I wouldn't have 5 in the total either. I'm probably going to have, 4 as a total, right? Because I'm having 2 cards out of the deck already. but I already have calculated each of the probabilities separately, and then now I'm going to find the probability of both. So I need to get the probability of blue and yellow. And we know, of course, that is getting the probability of blue. And then multiplying that, you know what, I'm going to use probability of blue times probability of yellow. That probably is a little bit shorter, right? And so that, of course, is going to be 1/3. And this is going to be 1/5. So we're having 1/15. Which, in my paper, I got 0.06 parodic. And that, of course, is going to be 6.6 parodic percent. That is going to be the probability here. So things change a little bit, but it's all in terms of the definitions we're working with here and understanding what's going on in the experiment. Okay? Now, if we work with problem number 5, problem number 5 is actually based on the same experiment. So I'm going to keep the parts over there. And problem number 5, it's to get the probability of red and, oh, I'm sorry, they don't use words, right? They use a comma on blue. Again, first card is fine, because the first card, I'm only getting everything as usual. So 3 out of 6, which we know it's 1/2. That second card, though, is where everything changes. I still have 2, yes, but my total is now 5. Okay? Make sense? All right. Now, I get the probability of those two things together, and that, of course, is going to be the product of the probabilities I get. So it's going to be 1/2 times 2/5. Let's just cancel things out, because we don't want to have to work extra, right? That's going to be 0.2, which is easy also. We already knew that one, and that is a 20%. See? That easy. And I'm going to do number 6, just because I know it can be a little bit tricky for you guys. It's not really difficult, but if you are not careful here, you're probably going to make a mistake. So I don't want you to make mistakes. And I don't want you to believe this is a hard topic to learn, because it is not. Okay? Now, it's different when you learn it in 10th grade and you have no idea, but you're actually getting the basics here, so you're fine. All right? Now, probability of yellow in the first card. Well, pretty simple, right? I have only one option for yellow out of 6 cards. That's good. Now, remember, I'm not returning the first card. So the probability of getting yellow in the second card, that's a little bit complicated there, because I only have one yellow card. So what that tells me is, well, I'm just running out of yellow cards. What am I going to do? Well, just 0. Of course, my total here is going to be 5. And we know that means 0, right? So, of course, the probability of getting yellow and yellow, I'm going to do it just because I want to show you, but I know you already know what I'm going to say, right? Well, it's going to be 1/6 times 0. And you and I know that is, of course, 0%. So it's an impossible event. We get an impossible event here. So keep that in mind, all right? Now, based on this, which is pretty simple, you guys are actually able to do everything else. And I'll see you later for lesson 16.5. All right, bye.